Welcome to another CO2 Experts Live. Super excited that you're here today, and thank you for continuing to come and learn a little bit about CO2, grow your knowledge. And this is what it's all about, uplifting the industry, uplifting your knowledge, and sharing this knowledge. As I say every week, anything you learn here today, share it with someone in the industry. Help develop them. We got to work together to grow the industry's knowledge, especially on CO2 as it continues to grow around the world. As I always say, it's not new to the industry, but it continues to evolve. Today, we have some special guests from experts from Bitzer, Tobias and Manuel. These guys, we were talking for about 30 minutes before this, going through some of the Varistep capacity modulation, the controller. And I'm blown away on some of the stuff that we were diving into. I knew a lot about it, but man, these guys are experts and shared a ton of technical tips with me before. That's what we're going to be diving into. If you have any questions and you're listening to this on the podcast or YouTube, put it in the comments. This is how we can get back to you. Ask questions that you need to know that really will help you develop your skills, as well as you're here today in the live session. Shoot it in the chat. Ask the questions. Have you been working on these before? And I'd love to see that in the chat, as well as where you're listening in from. Throw that in the chat as well, because we know their compressors are all around the world. I see them consistently more and more in racks. When I was at Chilventa there a few months back, I seen it on a ton of different manufacturers' racks. And this is the stuff that you want to dive into and learn about to find out. Because capacity control is on every CO2 rack out there. It's either the Varistep or the Varistep, but today we're going to be getting into the capacity control, the mechanical design of the Varistep. Tobias, Manuel, welcome to CO2 Experts. How you guys doing?
Hi, good morning, Trevor. Yeah, we are very excited to give you and all the people online the insights of the Varistep, why it makes sense. My name is Tobias Fuhrer. I'm meanwhile the head of Center of Expertise for the commercial refrigeration, and I'm here with my nice colleague,
Manuel Reichle. Pleasure to be here, Trevor, and thanks for having us.
Yeah,
I'm product manager for our Reciprocating compressors. Really great to be here on your show.
Awesome. Well, these are the experts, so make sure you ask the questions. Like I said, leave a comment, reach out to me, because these guys have been doing it. They've been working with the manufacturers all around the world, all the different countries. They were working with the technicians and contractors, so they've seen it all. Like they've seen it, and we were talking about it. They're like, "Hey, Trevor, we got compressors back where we've seen gloves in the suction builder." So this stuff happens, right? So we have to make sure that we're doing the things right, doing the setup right. And this is what we're going to dive into today, setup and troubleshooting.
Good. All right. Let's get going. Okay.
Yeah.
So before really going into the deep dive into the technical topics, a brief look onto Bitzer as a company. You have mentioned it, Trevor. We are worldwide active and represented in many, many countries around the globe, with 75 sites in 40 countries, and have 21 production sites, reached 1 billion in turnover last year, right? And the Bitzer family grows. We have 4,300 employees around the globe, and invest also. That's also the message here. We invest quite some money in R&D, not only for Varistep or for capacity control, of course, but that is a major topic for us also. So when we talk about reciprocating compressors, what are the main manufacturing facilities that we have? Made in Germany, reciprocating compressors means factory Schkeuditz, that is close to Leipzig, with approximately 800 people there. And there's also the competence center, that means main R&D really for reciprocating compressors. And when we talk about made in the US, Flowery branch in Atlanta, Georgia, with close to 300 people, where the majority of our reciprocating compressors are produced and assembled for the North American and also South American market. Okay, what compressors do we have? I mean, that is well known. Also, we talked about it before the session. Everyone knows our compressors on the left-hand side. That's for HFC, HFO, our Ecoline series. But and what we want to focus on today is really CO2. So the Ecoline CO2 compressor series for sub and transcritical CO2 applications, and those come as 2, 4, 6 and 8 cylinder models, and pretty much all of them can have the Varistep, so mechanical capacity control or unloading, what some people call that, to really, give a good balance between the system and the suction groups. Also, we want to focus really on refrigeration, with the 2 cylinders and the smaller compressors. That's more like convenience stores, smaller capacities, and then going up to supermarkets, hypermarkets. Also, industrial applications like storages, ice rinks is a good example. And what is common for all those applications, whatever it is, smaller, bigger, industrial, commercial, what is common for all of them, they need capacity regulation. They need to be able to go down quite low in part load, and that background is now explained better by Tobias.
Thanks.
Why that is needed.
Thanks, Manuel. Because we brought the example here of the scale. What we can see, the scale should be always balanced in the middle. So if the scale is balanced, we can run a stable evaporating temperature, a stable suction pressure. But the weights between evaporator and compressor and so on is influenced by a lot of things around. So the ambient temperature outside where the gas cooler is have a big influence on the compressor capacity. The hotter it is, the compressor performance will be a little bit reduced, whereas in subcritical, for example, the compressor has much more mass flow and therefore much more power. But also the capacity control method, for example, is on the left side, very important. If I don't have Varistep or variable speed, I can manage it by on and off, but then it will always dance like this. With a frequency inverter, I can really run it, let's say, quite stable within the range of the frequency inverter. And with the Varistep, I can basically do the same like with the inverter, but with a wider range. We will have some examples there in the later slides. The system design itself has also quite an influence on the compressors. If it's a flash gas bypass system, the empty compressor have to deal with the evaporator mass flow plus the flash gas mass flow. So and they have to balance the changing requests by the high pressure, but also by the suction pressure. If it's a booster system, the LT stage has an influence. If this is bringing more capacity inside or less, it can be seen as an additional evaporator, but it's bringing also, let's say, the scale into a movement. Parallel compression, then we basically have to see it as 2 scales. So the empty compressor has an own scale and the parallel compressor have an own scale. Of course, that the influencing is always a little bit the evaporator load plus the ambient, for example. So try to have both scales balanced is the challenge. The ejector brings the scales again into movement. So how accurate I can adjust the capacity, and I should do it without having any jumps in between. This is then the point for the rack systems where we'll have later some further slides. Operating method, if it's suction pressure control, cold room temperature control, have an influence. On the other side, also the evaporators, how much evaporators I have installed. Is there big size differences in the evaporators? The smallest evaporator have an influence because in the best case, I can cover with my capacity regulated compressor the smallest evaporator load in my system, which is not always possible. But we go later on when we talk about the supermarket application into one example. Then the operation, is it a supermarket? Is it a cold storage? If there is forklifts, the load for the rack system in the supermarket is quite different between opening times and closing times. So when the temperature in the supermarket is reduced during the night, the evaporator capacity or the demanded evaporator capacity is lower, than they put the the fences down, or they have closed anyhow already. The people don't open or don't bring any additional heat inside, has big influence on that. The challenge.
I have a question on that, because this is one of the things that for CO2 was everyone was like worried about the ambience being so warm. You know what I mean? It's always hot out and the hot ambience that CO2 doesn't work as well in hot climates. We know now with parallel compression we talked about ejectors. It can be all around the world. But when I first started learning CO2, no one really talked about the issues on low load situations. Now I'm seeing more and more of that being an issue where all of a sudden it's minus 40 out or minus 30, where systems are running into more problems. And then you just said it, you got curtains pulled down, it's in the middle of the night, everything is satisfied. This is where capacity control comes in huge. But have you ever seen it with some of the manufacturers that you may have worked with where they have to add something to keep the rack running? Because even with just the Varistep running at minimum, the load is still too low. Have you ever seen that?
With the Varistep, not so far, because we can really go quite low in capacity. With frequency inverter driven compressor selection, we had challenges with a high number of starts and stops, because if the compressor is too big, it starts and stops quite often if it cannot address the minimum load. And therefore, we have had some examples where we did also retrofits. We replaced Varistep against the frequency inverter. The situation with the frequency inverter in the wintertime was the compressor started, it went to 25 hertz, and after 1 or 2 minutes, it stopped again. Which was running fine for a couple of weeks or months. At the end of the day, the oil separator is not separating 100% of oil always, so there's always a little bit oil going into the system, which was not coming back because there was no running time, and the service technician was then called for lack of oil in the compressor because of the oil management system. They could not feed back the oil. So what they did is then they refill oil and the system was running. When we implemented the Varistep technology, then we added also our Bitzer OLM IQ. That's our oil management system, which works in combination with the IQ module. This oil management system can record the oil level in the compressor. It's not only a device that feeds back, it's also a digital sight glass you can see.
Okay.
And you can see the sight glass history in the data log over 2 weeks. And we upgraded the system and we investigated the data log after some time of operation. And we found out that the oil injection never called for oil. And we have seen the oil level up to 100%, which means the compressor was really full with oil coming from the suction side. We went back because it was a field test case to the service guy, and we asked them, hey, can you look to the maintenance log? Did you put additional oil to the system? Yeah, and then they find out different service technicians did 3 times refilled oil. So it was massive overfilled with oil, causing the next challenge for the compressor because it's running as an oil pump. It's not going good for the long term. So with that measure, we could adjust the system. And since then, we follow this online now. It's connected to a WOM controller. And we could see that it had 2 stops over 1 year. So it's running basically all the time between 30 and 100%. Sometimes we see 20% or 10% compressor capacity, but then it must be really a short period during the nighttime.
Yeah. And this is a question I've got over the years all the time. Well, when should I use a frequency inverter, or when should I use mechanical capacity control? And Tobias just said it there. You know, if you need a higher turn down rate, that's when you're going to want to probably go with the Varistep versus a frequency inverter. Is that correct?
Yeah, that's correct. We have later some nice pictures. Personally, I would prefer the frequency inverter, but I show you on the next slides then. Yeah. Going back to the presentation, you said it, the system gets a little bit more complex by parallel compression, ejectors, and so on. but also the integrated systems where you do refrigeration, air conditioning, and heating in one system brings additional complexity. The target of Bitzer is, or how we tackle these solutions is, we brought our IQ modules. A lot of things which are complicated to run safely around the compressor, we put these operating functions to our IQ module. For the rack controller, it is the same interface like to a frequency inverter. You give us the 0 to 10 watt signal, and we give you the capacity you want to have. Secondly, we have some monitoring of the operation parameters, so the sensor values and so on we have in our data log as well. So you can communicate with the compressor, which makes it also a little bit easier. Secondly, when we speak about the efficiency of the compressors, we want or we try to make energy efficiency increases very easy. Therefore, in 2016, at the Chilventa, we first time launched the so-called Ecoline Plus range. So the LSPM, line start permanent magnet motors, what you can use directly online without any electronics, and you have a more efficient compressor. Secondly, in Europe, we have the Varipack frequency inverters, which is very easy to configure and also to select, because you get the perfect match to your compressor. And at the end of the day, you have only to put in, this is my compressor type, this is my frequency inverter type, and then all the parameters which is needed to operate it are automatically set, so you don't need to go into deep frequency inverter values to do an optimized setting. So if you select the compressor, all the settings are optimized. Yeah, and then what we want to achieve is, when we speak about the capacity regulation, on the left side, we see the mechanical capacity regulation where versus the on-off operation, for example. So in on-off, we always start the compressor, it goes down. When it reaches a certain set point, we stop it, and then we restart it. So in average, the suction pressure is lower than if we can control the capacity. So a wide capacity modulation is always good to cover the minimum loads. And then we talk about the control factor. Later again, I'm going to explain it. The control factor describes the capacity steps between the variable capacity compressor and the fixed speed compressor. This is an important value where we have deeper slides on it. If you have a perfect capacity regulation, you have lower operating cost, therefore a reduced carbon footprint and a higher system availability, because your system is running without any, let's say, problems. You don't create any additional problems by too high starts and stops. You don't have running time on the compressors and these kind of things. So the systems are running really all the time and yeah, with less troubles. And Manuel is going to explain us a little bit more what is the possibilities and what is the ranges between the different options.
So yeah, first of all, what are the options? And I don't think there is a clear, there's advantages, disadvantages for using inverters. There's advantages, disadvantages possibly for using Varistep, with being able to go down to 10% is a clear advantage, of course. And option 3, what we show here also is a combination of both, and that is also coming next year, I guess, the best of both worlds, right? Mechanical capacity control in combination with the inverter. That is also something that I will
That's cool. So now we're saying that, because we know the compressor can go down, I think 25 hertz most. There's different, depending on the model and stuff. You always have to go in and check the application engineering, or go to Bitzer their web software and look at, because different compressors do different ranges. But and this one, for an example, it would go to 25 hertz and then potentially use unloaders or do one or the other. This is pretty cool. I'm loving seeing this. This is definitely making me intrigued, and I have so many questions already on that one.
Excellent. We have to have a separate session on that.
Yeah, that's for sure. I love it.
In the end, in my mind, it's also giving options, and in some cases, it's also a matter of philosophy where customers feel the most comfortable, using one or the other, or in future even both combined. combining those great advantages that we have here. And you have mentioned it. There is, if we just look at inverter control, depending on the compressor size, maybe compressor type, there's a certain frequency range with the 2 cylinders, 30 to 75 hertz, right? Which then percentage-wise goes down to 34%. And 4 and 6 cylinder, if we talk CO2, 25 to 70 hertz, which also gives them the minimum of 34%. Whereas using really Varistep here with 2 unloaders on a 4-cylinder compressor, first of all, option 3, the combination, I will come back to option 2 because that's the focus today. So option 3 is a combination. That means we have 1 unloader, right? And that is not.
Manuel, sorry to stop you for a second. Can you just go back? The slide I can't see the slide. Do you want to just go back to that slide again? Just go back 1 and then forward. Sorry. Option 1. Okay, go to option.
PowerPoint stuck. Okay.
Yeah, it was. Now go to it. It's stuck again for some reason on that slide.
Let me try to skip that and go to
option 2. Yeah, here's option 2. I can see it now. Sorry.
I want to focus on anyways. So let's focus on option 2, and that is really for the lowest, for the greatest range. Really, if you have on a 4-cylinder, if you have 2 unloaders, right, and then of course it gives you 10 to 100%. So that is really for minimum, to cover minimum part load operation, and for 6-cylinder compressors, and then with 2 unloaders installed, right, that's 33 to 100%. So, and that is really what we want to highlight and focus on today. Now, how does it work? When you look on a compressor from the outside, all you see is the cylinder head and there's a solenoid coil and a solenoid valve on the outside. So let's take a more detailed look how it looks like and how it works on the inside. First of all, the cutoff view on top, and below that we can really see the inside, also with the solenoid coil on top, and then the internal parts, mainly the control piston, which is then, when activated, is moving, and then that really unloads the cylinder bank. And when unloaded, of course, it doesn't contribute to the cooling capacity. There's no more mass flow rate coming out of that cylinder bank. And when it is unloaded, yes, please, Trevor.
So when that's energized, I just looking at, there's a little drill hole that goes up. Is that high pressure that goes in underneath that control piston and pushes it down?
So exactly the gas pressures or the flows are, the pressure differences are used to move the control piston, and that then internally connects high pressure and low pressure side, right? So that the cylinders basically no longer compress. And what you then want to avoid is that you have like a reverse flow from the system, from the gas, the high pressure side of the system, basically. So there has to be, and there is a check valve really on the valve plates or inside the cylinder head to prevent the moment it's unloaded, to prevent any flow, coming back inside from the high pressure side. Because one cylinder, the other one, cylinder bank could still be operating. So that's the basic principle here of unloading, and that is not really the blocked suction as we do on HFC or HFO compressors. That's a bit different principle here for CO2. Okay, so I got a question on this now. So when I do a lot of training, I talk about compression ratio is very important, and we know if you get too low of a compression ratio, that causes an issue with the compressors. So if you have really low compression ratio, what will it happen? Would that same thing happen to using a Varistep versus a fixed compressor? Because my understanding on a compressor, when you get a really short, small compression ratio or pressure ratio, that the reeds will not open or close properly, or they could flap, and then they cause some degradation, and then they fail. If you have too low a compression ratio, what would happen with the Varistep? Yeah, that is something I will come back to later on, where we also have our application limits. I mean, within what we publish, this is tested and that is verified, but you are completely right. I mean, at lower pressure ratios, at some point, the valve plates no longer function properly. I mean, a compressor is not a pump being able to do really, really low pressure ratios, and the same thing. So that is why we also publish, right, where it can be used and where it should not be used.
I love it. Okay,
sorry. I'll come back to
questions.
anytime.
But it's a good point, and we paid attention on this when we developed the valve plate. The valve plate for the Varistep is for the moment still different from the standard valve plate. So we paid attention that we avoid this flapping situation if there's no pressure difference. Secondly, is because we run it, let's say, in this internal loop, there's not really a big mass flow. So in a lot of cases, the valves will maybe not move really. So when it's unloaded, we have really also, because this is also important for the efficiency later on, when it's unloaded, it's really only the mechanical wear of the drive. Yeah. There's not really compression work done also.
Yeah.
Good. Now, real quick, there's suction and discharge, right? And if the compressor is operated at 100%, there's 100% mass flow. So both cylinder banks would be active. So if we go to 50%, that's also relatively easy. One cylinder bank is completely, deactivated. One is active, giving you 50%. So if you now want to operate anywhere between 50 and 100%, so that means one on here, the right-hand side cylinder bank would be active, and the left-hand side one would be cycling. That means, being activated, deactivated in order to achieve anything, any percentage number between 50 and 100%, say 65, 79, and so on. Anything below 50%, so 10 to 50%.
You have to put it again, yeah.
So the right-hand side cylinder bank would be off, and then left-hand side would be cycling. So making one off is already 50%, and then with the remaining cylinder bank, cycling, and then any number between 10 and 50% is achieved. Okay.
So would it be the same with this? So I know in a lot of your documentation on your fixed compressors, we want technicians to check the cylinder temperatures, right? So one cylinder versus the other, because one could be damaged. So if they're all closer to the temperature, are they going to do the same check on the Varistep setup?
Checking the discharge gas temperature with the Varistep is a little bit more challenging, especially when we go below 50% of operation, because we don't see a constant mass flow, and therefore we will always see a peak and so on. Therefore, we have this on the later slides also. It is mandatory to have the IQ module to operate the Varistep, because since we cannot simply cut off at 140 or 150 degrees Celsius, sorry for speaking in Celsius because I don't know the value in Fahrenheit.
284 Fahrenheit.
Yeah, 284. Simply stop the compressor, because the sensor cannot measure it because the cycling rate doesn't allow it. We had to implement an intelligent function to have a cross reading of what is the real temperature now versus the measured temperature, and for how long time we can, let's say, accept the high temperature. And because everything is overheating, if at 10% constantly, the oil will get too hot because there's no suction gas flow enough coming to cool it down. There is the discharge gas temperature can be exceeding the 284, and we will not see it. So therefore, the IQ module has a special function to monitor all this situation. And when after a certain time, this is depending on, did I operate the compressor at 100% before, at 30%? What was the situation before? The time is always different, how much I can run it at 10%. But if the IQ module is then detecting that the compressor gets too hot and we need a cooling, it will override the signal, and it will say, okay, I run the compressor not with 10%, I run it with 20, and then it increases up the steps, step by step. with this measure, we force the rack controller for a reaction. If we don't do this, we will end up in a broken compressor or in a compressor that at some point will show a discharge gas temperature far away from 284, 300, 350, easily possible. So therefore, we increase the speed or the capacity of the compressor, and then the rack controller identifies, I have too much capacity in the system. I need to stop either this compressor, if it's the only one which is active, or if we have a compound system, it stops compressor number 2. Compressor number 1 will automatically run then at 80, 90, or 100% and gets the full mass flow, is cooling down again. Everything is fine. We don't create any alarm or any unnecessary stop of the compressor. We brought the compressor out of that critical situation without making any trouble, let's say. This is a function which we tested 2017, and since that we didn't hear any problems with that function, because nobody is really going to recognize it, that we are, let's say, overriding the signal. Yeah. Speaking about efficiency, because this is always, let's say, a big topic, and it's not possible to calculate it at the moment in the Bitzer software. It's also something where we work on. We have a quite long list of what we want to do with the software, but maybe at some point we can have it. Therefore, we did the calculation now by ourselves. So we have here flash gas bypass system. The values for the compressors you can see on the top line. The important things is on the right side, we have the compressor. It's a 4JTE with variable speed, which is the bright green line. It can go from 25 to 70 hertz, which is 37 kBTU per hour. And in the top, it's 115. Whereas we selected one size bigger Varistep compressor from the displacement wise, because we don't have the capability to go to 70 hertz. So it's calculated with 60 hertz. Then we have to select the 4HTE, which is one size bigger. This compressor is doing then 118 kBTU at 100%. And roughly 15 kBTU at 10%. So it's a much wider range. So if we focus now on the range where I can compare these two compressors, the comparable range is between 29% and 69%. At 29%, because also the compressor loses some efficiency if we run it with lower speed in CO2 in this operating condition, the COP of the Varistep is around 7% in favor. So it's better in COP versus the frequency inverter combination. And the higher we go, so at around 50% for the Varistep compressor, which is then around 40 to 45 hertz, we still have, let's say, 5% efficiency increase versus the variable speed compressor. And if the CO2 compressor is running at 70 hertz, the variable speed, we have a flat situation. So, of course, this is now a transcritical operating point. In subcritical, it looks a little bit different, but in average, depending on what you calculate, if you compare the Varistep and the frequency inverter in the comparable area, with comparable, let's say, displacements, then the Varistep and the frequency inverter are from the efficiency-wise always on the same level, with a small tendency that in the range the Varistep has a slight benefit, so 1 or 2% in average over all the families. But if you would ask me, I would say efficiency in the comparable area is the same. Yeah. So we can cope with that.
Yeah, and I think that's a big thing. So that's more on the manufacturer side versus the technician and contractor side. But if you are building with these compressors, you need to go through each one of these steps and get into that Bitzer software, or reach out to your Bitzer rep to walk you through that to see what is going to work. Because both of them, as the technology starts to evolve, we're making it easier and easier to work on this equipment with the IQ modules and the way the manufacturer's set up. But you're going to have to reach out to them to just double check that. Like, is this 1 or 2% worth it versus the complexity potential? So, and who's going to work on it afterwards, depending on what part of the world you're in. Do you have someone that can go out and service something that's a frequency inverters or something that's a mechanical control? It all comes back to the controls, but that's what you got to think about before, designing a system.
Yeah. Varistep is let's say, universal solution. You don't have power electronics involved and these kind of things. You don't have EMC topics with the cables and so on. So it's efficiency wise from the capacity regulation point of view equal to the variable speed compressor. Yeah. So now coming to the system design, we spoke about the CF factor earlier. The CF factor is not an invention of Bitzer. It's coming from the so-called ASOCOM, which is the Association of European Refrigeration Component Manufacturers. Bitzer is part of it. All the other compressor manufacturers are also joining this. And together in this group, there were guidelines for multiple compressor rack system using frequency inverters at that time. They did this recommendation, what you have to consider if you do this kind of systems. Out of that, this we highlight here because they explain this CF factor. It comes out of this document. Bitzer used it also in its own documentation, the AT 744. It's a technical advice, I would say, where we have a little bit more holistic approach also with the LT stage. For this time, it makes it too complicated. But out of this ASOCOM guideline, the CF factor is describing, it's the calculation, what we can see. This is the capacity of the variable speed or variable capacity compressor, maximum minus minimum, divided by the capacity of the fixed speed compressor. So if this range is bigger than the fixed speed compressor, we get a CF factor of 100, which is ideal. It's perfect. And it's very easy to do it with the Varistep. It's more critical with the frequency inverters, but more on that on the next slides. If you have achieved a factor of 80%, it's still okay. But you start to, below 100%, you start to have gaps where your compressor combination cannot fulfill the demand from the evaporator. You either offer too much capacity or too few capacity, and this brings your system into an imbalanced situation. If you stay in this area, you will also always have a start and stop of the compressor. The point is, how big is this gap? If we speak about 500 of 1 kBTU or 2 kBTU, it's maybe not so dramatic. If we speak about 20, 50 kBTU, the situation gets more worse, and the bigger the gap is, the lower the factor is. The Bitzer recommendation is, because of the green color, try to make it over 100%. If we look to the supermarket, we have, again, our scale of the evaporators now changed to the left side and the compressors on the right side. We have to design the system for the summer conditions, which is defining our maximum load, and the winter conditions, which is defining our minimum load for the whole setup. Then we have installed a number of evaporators in the supermarket. So out of that, so we have cooling furniture with 20 kBTU, some with 10 kBTU. So depending on the amount, you can also calculate how much furniture is equal at the same time active. It's also a question what you assume there. For my example now, I assume that I have to go with 40 kBTU out of that situation, which means that only two of the big furnitures are on. Or so in total, we have installed 360 kBTU in this combination here. So 440 kBTU is what we try to achieve in the winter conditions. So my target is that my rack combination in the summer conditions can do around 345 kBTU, and in the winter operating conditions, I should achieve the 40. Then I can cover the demand of two big furnitures, or four small furnitures, or three, two small and one big. As a calculation, we used 104 Fahrenheit as the gas cooler outlet temperature, 18 Fahrenheit evaporating temperature for the summer conditions, and in the winter condition the system is running subcritical. Then we calculate with a 60 Fahrenheit condensing, which has an influence on the lead compressor, because this is defining the minimum capacity in the winter conditions. If I look now to a first selection done in Europe in some supermarkets, because the challenge is I want to have 345 kBTU, but I don't want to spend the space for more than 3 compressors. And in this case, and they also tried to pay an attention that the winter capacity is not so far away from the 40. So they put in a small variable speed compressor with 25 to 70 hertz. The problem is the next compressor is in the 60 hertz volumetric volume, as double as big as the first one, which gives us a big jump in here when the second compressor is starting. So in this point, the lead compressor, this one is running with 70 hertz. Here it is running with 25 hertz. And then when this is at 70 hertz and the combination is restarting, the lead compressor goes back to 25 hertz, and the second compressor is then on with 100%. Then I have a big jump, and all the evaporator request in that area cannot be covered. So I either have too low capacity or too high capacity, and then I have a high number of starts and stops. The situation gets even worse, because to achieve the summer capacity, I had to select a compressor that's roughly 2.5 bigger than the first one. So the jump here is quite even bigger. Okay, the controller could also address this because he could stop this compressor and then start this compressor first. Then he would have a different scenario here, which make it a little bit better. But from the CF factor itself, it does not make a big difference. We have areas where we cannot cover the evaporator load, which is not so good. If you have such a system and the winter capacity is more or less acceptable, because you have enough evaporator power in the winter, you can update that systems by replacing, for the moment, the second compressor with a fixed Varistep. This means you run the compressor 50 or 100%. Then you can start the second compressor with 50% first, and you don't offer too much capacity, and you have a well-balanced system at the end of the day. However, in the winter, the system is not perfect now, because you cannot go down below 52 kBTU in this example. If you want to have a system with one variable speed drive that can manage the below 40 kBTU, you have to select the 4 MTE compressor, which is roughly, not completely the half displacement of the lead compressor before, but 3/4 of that. So we have And if we go with equal compressors now in this scenario, we would have to install 8 compressors to have it. We would have a perfect capacity regulation and a perfect gear up, but we would need to install 8 compressors. As Bitzer, and I'm in sales at Bitzer, I like this solution because we could sell much more compressors per supermarket. But it's not a solution that is really practical. So therefore, just to show, if you want to go to the 40, it is not so easy with the variable speed drive. If you do it with the Varistep and an easy execution, you can have the 40 kBTU or below 40 kBTU by selecting the biggest compressor in the configuration is now with the Varistep, the lead compressor. It's not the smallest anymore, it's the biggest. In this example, it is not the most perfect example, but it's the easiest execution with 3 compressors. So 10 to 100% with a 4 DTEU, or you can also use a DTE. The DTEU is the LSPM configuration for a little bit higher efficiency, or for higher efficiency. And then you can gear up with the GTEs easily, and you don't have any, let's say, areas of no coverage. It is perfectly running by only having 3 compressors installed. If there is no space available, we don't recommend it really to do such big systems with a 2 compressor execution. For smaller capacities, it is standard to have only 2 empty compressors now with the Varistep. But even you can do it with 2 compressors, whereas with variable speed drive, you would need 8. With 2 compressors, one 10 to 100%, the other one with a 50 to 100 equal displacements installed. In this case, you can go down from 33 to 334 kBTU with only 2 compressors versus in the other case the 8. Our recommendation to do thing is a little bit similar to the variable speed drive. And I see I have one issue on the slide. Here should be the HTE and 10 to 100%, followed by an FTE with 50 to 100% and for DTE 100%. You can go down to 50 kBTU. You will have approximately 30 hertz, 30% capacity at 40 kBTU. So the efficiency is very good in the low load situation. And you can gear up until 334 kBTU with only 3 compressors, and you can cover a very, very large range with 3 compressors installed. So this is a quite nice situation. So balancing the system between maximum load and minimum load gets very easy with the Varistep due to the range of the 10 to 100% of the lead compressor.
Yeah, and this is going to be a balance for the manufacturer too, because and end user, because now 8 compressors cost way too much. You're not going to go do that, and then only 2 compressors, like you mentioned, one fails, then you don't get anything to help you out. But if you have 3 or 4 that's in between, if something happens, a valve plate damages or something, that you still can keep the system going. So that's something you want to talk about with your customer, or if you're a designer or engineering firm out there, you want to have a good understanding. And most do today. The most manufacturers I work with, man, they're real smart, so they're understanding the differences on that. But that's something you look at as you should think about. Any rack or any parallel system is like, why did they put this many compressors here? What is the capacity of it? And the biggest thing is the gaps as well. Like you said earlier, if you have a big gap and it's real low load in the middle of winter, a compressor bangs on, bangs off, bangs on, bangs off, then you get oil issues and then lots of other not good quality of cooling. So, and it definitely makes sense.
Okay, Manuel will take over now.
All right,
and talk a little bit about how the Varistep can be then controlled from the electrical side, what I have to do there.
Yes, and I'm not sure, Trevor, how much more time you allow us. I'll try to be quick and then show the rest of information that we have here, how to integrate it really, and to control the Varistep. That is done by the IQ module that has now been mentioned a couple of times, and that could be done in combination with extension board CM-IOA, on which you then just provide a control signal from the system controller, right? The capacity signal, 0 to 10 volts, which then activates and deactivates the Varistep accordingly, depending on what capacity is really needed on a given compressor. And to monitor and also to supervise the discharge gas temperature, there is here connection possible to integrate the discharge gas temperature. And also you have mentioned it earlier, when you turn down the capacity too much and the mass flow rate, at some point motor cooling could become a topic, right? So that's why the discharge gas temperature is measured. And if a certain limit or threshold is exceeded, then the capacity by the module itself is increased for a certain amount of time in order to cool down the compressor, again, the motor, and to bring down the discharge gas temperature in the end.
So is that a specific sensor? Is it a 10K and 86K? Is it a specific one for that one? Just say one fails in the field, they check the resistance. What would the replacement be for that sensor? And does that come with it? Because I think I tell every technician, you got to be putting discharge protection on your compressors, because if you get overheat, the compressor is going to die, and it costs a lot more money than a $20 or $30 sensor or whatever it costs. You know what I mean? But is it a specific discharge gas temperature sensor?
That's a PT1000, and I mean you can find it on eParts on bitzer.e or bitzer.com, and find the part number there. Right.
It's a special sensor in this case because it's measuring in the discharge gas flow. So it's not on the tube, it's inside of our compressor.
Screwed in. So there's an 1/8 NPT thread to really screw it into the housing to measure inside the gas flow.
Even better. So it is a specific one. So you just order it out. It's just a PT1000 sensor, but it is one that goes inside the compressor. Does it go in the head of the compressor? Is that where it would go, on the right side, or what side?
In the common discharge flow, let's say. So after the cylinder head, but in some cases, like before the discharge shut-off valve.
Yep, makes sense.
Good. That would be this. And how to access the IQ module. That can be done with a laptop, can be done with a cell phone via Bluetooth, right? Using the best software, Bitzer electronic service tool that is also then used to set up, to choose certain configuration, how many Varisteps do you have installed, and also afterwards to look at the operating profile and how whether there was any alarms, and the operation basically of the system and of the compressor. And that was a question earlier, where to operate and to avoid anything too low pressure ratio down here. So this is then given by the application envelope, by the application limits. So this
is a little bit misunderstood. You can run this also. In this area, we don't expect any interference of our IQ module to the capacity of the compressor. If you run here in that area, it might be that in some time the IQ module will start to increase the speed.
And on there it says you need a 10K. So in the gray area, that's not green. So that says that you need a 10K or 18 degree Fahrenheit superheat at the suction, right?
Yeah, that's correct. But that is
that for
whether Varistep or not.
Yeah, exactly. And is that for both transcritical and subcritical, or is that just for the transcritical compressor?
On the transcritical ones, we state the application limits for 10K, correct? And for subcritical compressors, we state that for 20 Kelvin. Those really usually require a bit higher superheat due to the operating condition. They run a bit colder, so you want to run them a bit warmer in order to have a certain oil temperature, in order not to have that much CO2 being solved in the oil. That's the background on the subcritical machines or on the subcritical conditions.
Yeah. And this doesn't matter if it's Varistep or capacity control. This is compressors in general, even they're fixed compressors. So you got to really watch that. You got to check this on all the compressors when you're out there, is check the superheat on all of them to make sure it is above that. Perfect.
Very correct.
One number we want also to highlight, we have the Varistep since 7 years now. So, and we have 4,100 supermarkets running with the Varistep as lead compressor. 4,100.
Okay, wow. Yeah.
Then if it is used in stepped, so basically 50 or 100%, you will also find the application limits in the Bitzer software, where there is just slight, let's say, restrictions on the thermal limits. So that's the top left-hand side corner of the compressor, where in typical, cooling and in freezing applications, you don't operate the compressor anyways. It's more something for heat pumps.
The IQ module will, in this configuration, it's possible to run it also without the IQ module in the 50 or 100% execution. But for the area of stepless control, the IQ module is mandatory to protect the compressor.
And this is so important as a technician to understand, because a lot of the people, like, they hear about operation envelopes and permissional area, but when you're in the field, you're not always looking it up. This is why I keep saying you got to go into that specific compressor, because this operation envelope, they're showing multiple operation envelopes here for different compressors. They're going to have different envelopes, and you got to stay inside that. This has all been tested by them, and they know if you're running high discharge pressure and a low evaporator pressure, you're outside that envelope, which is going to cause damage to the compressor. It might not fail right away, but this reduces the lifetime of that compressor. So when you're there and you got your gauges on, or you see the pressures, or you're looking at the best software, you got to look at these trend graphs to get a better understanding of why this is happening. So you understand when you're servicing the compressor.
Yes. So now I try to win some time because we already connected now. You could see it in the video during you was talking to the IQ module. We connect by the Bluetooth. If you go on site and you think that your system is not running, so for the troubleshooting, you have an issue with the Varistep and you want to control the Varistep, the first thing is what we recommend is to connect to the module, to download the data log, and then it takes a little bit time to process this data log because it's quite a high number of data, and you can see the circle is still running. When you have connected to it, you will get, of course, all the alarms, all the warnings you can see in the operational graph, but also you can see it in the alarm history, so you know what was going on with this compressor. And if you open the counter and statistics area of the best software, and you see a compressor that is looking like this one, for example. In this case, the compressor running statistics show that the compressor was running in average 0 to 4 minutes. So it was starting, running maximum 4 minutes, in average something like two minutes, and then it stopped again. Also, the number of starts per hour is an indication. 15 to 19 starts per hour is quite a lot. So the system cannot control the capacity properly. Something is wrong. If you see these statistics, it is really important to check the Varistep if it's functioning, if the solenoid valve is okay, and these kind of things. Also, what you can do is, for example, if you have a controller that can give you the number of starts and stops of the compressor per day, if the compressor is starting more than 120, 130 times per day, it is maybe at the time to pay the system a visit and to check because something is wrong, because you have a high number of starts and stops. In a good balanced system, we will see in the next data log. So when the system is running good and good balanced, we have an average operating between more than 5 hours. So it is not stopping, and 0 to 1 stop per hour basically all the time. So this compressor had in 54 days 23 starts. So this is not really a lot. Of course, at some point you reach the limits of the compressor, and then it has to stop. But 23 starts in more than 1 month is acceptable. It's less than 1 start per day.
I think in the service guide, it says you guys, on average, you want 6 an hour, less than 6 an hour. Is that right?
Yeah.
On just your standard compressor. So once again, there's more than one compressor guide to read. So they got a lot of different types of compressors. So when you get in there, they'll have I've read a lot of them, but you'll read their main guide for their fixed compressors. And then you'll have the capacity control guide for how the capacity control works. Then you'll have the CO2 guide. There may be information from that very first guide that relates to the CO2 compressor, because once again, refrigeration is refrigeration. It carries over. We do not want liquid to go into the compressors. We do not want the discharge to run really high. And this is why the more manuals you read, the better information you'll have when you're doing the troubleshooting. Just like reading those trend graphs. It's so important in this one that you have here.
Yeah. So this is now an operational graph. I told you earlier we replaced one Varistep. We take off the variable speed compressor. And in this case, we can see how on the lower black graph, we can see the reference signal from the rack controller, which capacity we should drive in this point. The green line is the oil level. This is the digital side glass. So we have something 58%. So there's still coming a little bit oil from the suction line, but it's not critical at all. We have always the side glass in the minimum, but the thing is, in these 3 hours, what we see here on the graph, we didn't need to inject oil. So the oil management system is useless. This shows also the Varistep compressors have a very low oil carryover rate. They don't. In this case, it didn't call for oil. It lived with the oil that it got from the suction line. So this is also with the Echo line quite a good achievement what Bitzer made. Then we can see the suction pressure, which is always around the 23 Fahrenheit, which is, we expect the set point of the controller, of course. But we can see there is different load situations because the load of the compressor is going up and down. So the evaporators call more capacity, less capacity, but the system can control this quite good. Of course, the condensing is going a little bit, or high pressure is going a little bit up and down. Of course, because the condenser or gas cooler is charged with more or less capacity. This is clear. This part of the system has also to react on it. But once this is made, it really, you can have a system that is close to run with a flat signal. This is quite good. For the troubleshooting, we have the KW234 maintenance instruction. You can find this in the Bitzer software. So when you go to the area documentation for the transcritical compressors, there we have a very good description. Also, we have a maintenance manual if you want to replace a valve. Then there is a video instruction what you have to do, what you have to pay attention when you exchange the valve. And also there's a guideline of troubleshooting, how you can identify if the cylinder bank is working or not. I think, Trevor, you read it already.
Yeah, I definitely, I read as much as I can, so I can ask good questions, and I understand when I'm training people on these compressors. So I do have definitely a few questions for them. So if a technician doesn't have, say their phone's not working, you know what I mean? Their phone is dead. What are like maybe 3 or 4 things that they can check on one of these compressors to really help let them know what's going on? For an example, these are an unloading compressors. When you're 100% capacity and you're on the amps and you're checking the amps are going to be the highest it is depending on those conditions, your suction and your discharge. But when it unloads, all of a sudden you're going to notice those amps drop off. There's no linear relationship with this because it all depends on conditions of your suction and your discharge. Do you want to talk about 4 or 5 things that they can go and check to verify that compressor is running operation properly?
So I would bring the system into kind of stable conditions. A little bit higher suction pressure is maybe better than too low. So if I run the system at stable conditions, I would take off the solenoid coils from the compressor. Of course, we discussed this earlier before the call. We should take care that we don't overheat the coils. So we should put a screwdriver in or disconnect the coils from the plug. If I have done this, I can come with a permanent magnet coil, and then I would check if I would measure the amps in full load condition, and I would measure the amps at 50% operation, first at the left side bank of the compressor, and then I check the 50% of the other side. So left side for me is from the motor side, is the side glass side, and the other side is again the opposite of the side glass, and then measure it both offloaded, and then you can also, let's say, check your suction and high pressure, and you can put the values to the software, and you can calculate the 50% values as well. That this way you know that mechanically the capacity regulation is working. If you put it back and it is not working so well, the second thing is what you can pay attention is, does the module get the 0 to 10 volt capacity request signal correctly? Because if this is going, let's say, from 5 volts to 10 volts and it's dancing up and down, jumping, then the controller can also not react, or the IQ module cannot react perfectly on this, because it also needs a stable signal, and not saying I need 70%, I need 10%, I need 100%. So checking the 0 to 10 volt signal is also an important thing. Then the IQ module have also LED side glass with 3 LEDs. The green one is if there's power. Then we have, if it's green, it is okay. If it's yellow, there is a warning. We are in a condition. This is not so nice, but it's not critical. There's no demand to stop the compressor. And if it's red, the compressor has an alarm and is stopped. And if you want to read out what alarm is, you need to recharge your phone.
Yeah, no, definitely. And so, for example, if someone never came up to one of these capacity control compressors, when they put the solenoid on or when they unload, the sound changes. So can you talk a little bit about that? Because that's pretty important. The first time I've ever seen a capacity control or even block suction compressor, you could hear it change. And if you've never seen that before, it kind of gives you, maybe there's something wrong with the compressor. Do you want to talk a little bit about that when it's loading and unloading?
Yeah, the sound changes because we go from basically a 4-cylinder operation to a 2-cylinder operation. So the system gets a little bit, the compressor configuration gets a little bit imbalanced. We try to make it as balanced as possible also for the unloaded situation, but the reaction of the compressor from its vibration to the system is changing, and therefore you can have also noises, of course. Yep. And then by of course the whole load situation for the machine is also changing, and therefore because of the frequency, the output frequency is now 2 cylinders versus 4 cylinders. The sound itself changes, but this is not critical for the compressors.
No, but what is important though is that all of a sudden, if it's calling to unload or unload and the sound doesn't change, then you will want to look into that, because now maybe that solenoid coil is not working properly. You're not getting the output of the 24 volts to it, load and unloaded. Maybe that 0 to 10 volts is not working, like you talked about already. So these are some of the things that you really want to go in. It's all in the maintenance guide and in the instruction, but these are some of the things that you have to check, especially if you haven't worked on them before. One of the biggest things is that we'll have to do another one just on the wiring diagram, because that's so important. Their understanding of what to check physically in the IQ module. Yes, you have the best software and all this stuff is great, but you have to understand it mechanically. So this is using your meter. Does the compressor have the proper voltage? Does the IQ module have proper voltage? Does the solenoid output voltage going out to it getting the proper voltage? Because there could be wires that are pulled, they could not be connected properly. So there's lots of these things that we need to check as technicians in the field. But this is awesome. Definitely get out to the manual, the maintenance instructions for sure.
Or get out to manual, to the manual instruction into manual.
All right, and I think I agree. It's a good idea to do another webinar on the the do's and don'ts and really troubleshooting, and maybe we can also prepare some videos or on a live demo or something. I could even imagine that, like on a compressor and connect something or measure something.
Let's do that.
For today, I think it was really great. To be able to talk about our Varistep, how it works, and I think we all agree how important it is to have good capacity control and to have a certain range, and also not to forget about efficiency and not to forget about the amount of compressors, where sometimes there is really on site, there is restrictions, so that you need relatively large compressors, and then it's even more important to be able to unload those. And in the next step, I mean, as the systems become a bit more complex, like with ejectors, adiabatic gas coolers, additional air conditioning load possibly, or heat recovery, additionally in winter time. So all this then adds up to, we need good capacity control for different operating conditions, and for summer, winter, as Tobias pointed out here and explained. So in the end, in a nutshell, less trouble and highly efficient systems. Of course, that is the goal. That is what we want to achieve, where Varistep is really a great technology to accomplish that.
Yeah, okay.
So
let's dive into some questions before we finish up here. You can skip to the next slide so everybody can see your contact info if they want to call you at 2 o'clock in the morning when you're troubleshooting a CO2 system. Can you advise advantage of CO2 refrigeration pack over ammonia pack? That's we're seeing this go. You guys do both. You got compressors for ammonia, you got compressors for CO2. We're seeing the transition in big, large industrial CO2. It's a very efficient refrigerant. So is ammonia. Both of these refrigerants are going to stay. This is my opinion. We're going to see it in different applications, but you're going to see CO2 more and more in industrial applications. Just because a lot of the advantages. What are your thoughts on CO2 in larger applications, heat recovery, things like that?
Yeah, that is coming more and more, and I think there's pros and cons. I mean, some people really think that ammonia is a bit more difficult for service, due to the properties of ammonia. But we do see CO2 really more and more. But I could even think about a combination of both, right? I mean, I could see ammonia in the medium temp stage and CO2 in the freezer stage, like in a cascade configuration.
Oh yeah,
would also be a nice combination. But for example,
sorry, go ahead.
Ice rinks, right? Using ammonia with glycol is one thing. Using CO2 even underneath the ice, for example, having that uniform temperature distribution, that is another example, right? And then not having the temperature difference in the cascade or glycol heat exchanger and so on. So there's certain advantages of CO2.
Oh, for sure. I've seen it too. And I talk to industrial technicians all the time. They're like, I don't want to work on CO2. And then I talk with CO2 guys, I don't want to work on ammonia. So it's, you know what I mean? It's refrigeration, it's what you're comfortable with. And both of them are good solutions for sure.
Definitely. So also, when you want to build a bigger system and it's close to the city or even inside of the city, then it's a little bit difficult for ammonia to get the higher charges. Then I see if there is restrictions from not from the system itself, but from the refrigerant ammonia to get the release to operate it in a dense area. It's more complicated. Then reducing the charge is one thing, but then also CO2 is easier applicable in this kind of applications when we are more in the industrial outside. Big slaughterhouse and so on, and the charge limit is not really a big topic, and then you can operate ammonia easier. Then it's also good, and it's also we see also that some countries have a different approach. We have countries they stick more to ammonia in large sinks. They don't want to touch CO2 in these areas. Other countries they go very strong with CO2 because they don't have the focus so much on ammonia. But to tell really what is better, also there we don't have a recipe in Bitzer, because we try to provide the best solutions for both applications. We are good in screw compressors with ammonia and with the ammonia packs, definitely. But we also have, and sorry for that, the best CO2 compressors on the market. So we also try to push these as well. So and we see a lot of nice installations with our products, and we are very proud of that also.
Yeah, you should be. There's another one here. So you're going to have to add Ireland to your map. Somebody mentioned that it's missed there, a good friend of BL. Yeah. Can the IQ module communicate with system managers like the SM800A, the Boss, the E3 or E2 or Corel? Can they communicate?
The IQ module itself can communicate if the protocol of the IQ module is available in the system manager.
Okay. So that would be like the map of the IQ module. Is that something you would the contractor could give to their programmer and install that? Is that what you mean? Like those parameters?
Yeah.
Okay. Yeah. And so they got to reach out to you to get those that information, or how does that work?
For example, it's they have to get in contact with us, but also more important to get in contact with the provider of the system. We don't hide anything, so our protocol is open. We have in the best software you can read out every temperature, you can read out every alarm warning, everything. You can send us also the capacity reference and these kind of things. Once this protocol is implemented, so we have rack controllers that are able to read our IQ module. So Danfoss have one platform where they can read it. Worm for sure, they can read it also. It's our controller brand. So and also others are working on it. There is one from RDM that is also able to read our Modbus. And the plant managers, if they can read it, they can transfer all the information they would like to have.
Another question: how can we use CO2 system with high ambient, like 40 degrees Celsius? Well, great question. CO2 is in every part of the world, even above 40 Celsius. I've seen CO2 systems. So you just have to. It has to be designed correctly with the right high ambient strategies. Next question was answered. Do LSP motors need a speed drive? Well, I think earlier you said you have Varistep with LSP motors, right?
So that is LSPM, line start permanent magnet motors. They can use a frequency inverter, but they don't have to. They can also run, for 60 volts, 60 hertz direct online.
Perfect. Is Varistep now available for all 2-cylinder and 4-cylinder CO2 compressors?
4-cylinder, in 6-cylinder, and 8-cylinder. In 8-cylinder, we only run the staged configuration, but it is available there. 2 cylinders, transcritical are possible on request. We should talk a little bit about the application before we release it. It's there. If you want to order it, 25 to 100% is possible. But since with the small system and stopping and starting the mass flow, we should a little bit talk first. If it's a condensing unit and you have a high suction line behind it, long suction line with volume, it is okay to use the Varistep in these executions. But if you have a compact chiller, let's say with a braze plate heat exchanger directly after the compressor with couple of inches suction line, so then the stopping and starting the mass flow is not the best idea. Yeah. So this is why for the 2 cylinders and the smaller capacities, we always try to get in contact with our customers, but it's possible. On subcritical, we get also here and there requests, and we look into that together with our OEM customers to offer a solution here in the future.
Somebody asks us where the people can find more information about that combination 2025. I think that's the Varistep and the Varispeed or frequency inverter. Do you have information yet out there or no?
There is more to come. That is a bit also looking into the future. So we ask for a bit of patience, and once it's time, then of course there will be information on the homepage, and we also then send out, let's say, the information via email also.
If you have an interesting project, send an email to Manuel or me. We can look into that because the software is ready. We have it in field trial, so contact us and we check what is possible. Of course, we try to do a webinar on that also and publish more information by 2025.
Yeah, amazing. A couple more here. Thank you so much for your time. So the question is, what is the cycle time for the pulse of it, or is there a cycle time on loading and unloading?
It's not a fixed cycle time in the IQ module, but in average, the cycle time is around 30 seconds. 30
seconds, okay. Because it's dynamic. I think you talked about that already. Because now it's not really coming from the Danfoss controller, the E3 controller, whatever. It's coming from the IQ module that's actually cycling it. And I think that's it, guys. This has been amazing. I learned a ton. Where can people learn more about you guys, learn more about these compressors, or find out more?
Yeah, we have several seminars in Bitzer in our academy. There you can check out the Bitzer homepage, the academy homepage, for example. Manuel and I, we are very often in exhibitions actually, so talk directly to us if you see us. So normally we are friendly.
I love it. I want to thank you. I want to thank you guys so much for taking the time to share some of this knowledge with us and just teach us a few things. I appreciate it and look forward to seeing you guys at another CO2 Experts. Thanks everyone for taking the time.